This video gives an introduction to Python for one of my courses, particularly the 1 or 2 sort of day courses. If you're interested in my full deep learning course, I have a link to that in the description as well. The course will be taught entirely in something called Google CoLab. You'll be given links to each of the modules that we're going to work on, and the link will usually be to GitHub, which you see here. GitHub, you can view the notebooks that I'll show you for the course in here. These are Jupyter notebooks. They can be used in Google CoLab so that you can run and not have to have a GPU on your own local computer. You can use a fairly high-end GPU that Google gives you for free. These GPUs are very important for deep learning. So I'll give you links to pages like this. This link is in the description of this video, but it shows you just some introductions to Python and to how to use Google CoLab. All of them will have this little badge here that says Open and CoLab. GitHub is just a source repository. It's where you put program code so that you can track changes, collaborate, do that kind of thing, but you can't actually edit and run these notebooks in GitHub. So we're going to open them in CoLab. All right, now we are in CoLab, and we can actually run things. So a CoLab notebook, a Jupyter notebook, you have text blocks that I tend to put in to explain things. They're written in Markdown, so you can change the font size. You can create links. That's a link to my web page. You can also have code blocks, and the code block has Python code here, hello world, and the output. You can change it and run it and see the different result now. It takes it a moment for it to start up the virtual machine in the background. And now you have hello world. By the way, while we're talking about notebooks and runtimes, you can change the runtime type, and you can choose a hardware accelerator and run with a GPU. We don't need a GPU for this introduction, but you may want to do that during my course. I'll tend to tell you in the class when you want to use a GPU or not. You don't want to be wasteful and use the GPU when you don't use it. 1, that's just not nice to Google, and 2, they're more stingy with the GPUs that they give you if you waste them a lot. So that's hello world. This is how you print something in Python, and you see the quotes around the string. We'll do a lot more complex than that. You can also put comments in. So the £, that is a comment. It's not a hashtag in Python. So you can put these around it, and it will still function. It does not do anything that is behind a £, or a hash symbol. You can also use single quotes for strings. There's really no difference between single quotes and double quotes. The language is nice, like many other languages, and lets you use one or the other. In some programming languages, there's a very big difference between single quote and double quote. You can print numbers. You don't need to put the little quotes around them, because the numbers, you can perform math on them, and you couldn't do that if you put the quotes on it. So you can add 1 to that or something such as that. You can assign variables. Most programming languages have variables. Python uses a single equal to represent an assignment. So that's assigning A to 10. That's assigning B to a string of 10 ten. Then you're going to print them both out. And there you have it. You can do mathematics on things. You can do A equals 10. You print A equals A plus 1, and you'll get 11. You can also do it like this. That would also add 1 to A. So we set A equals to 10, and we can print out the value of A is A. It'll print out 10. Notice the F in front of there. It's an F string. The F string just means that these little curly braces will work. You can put any code that you want to, within reason, between these curly braces, and that will be what is evaluated and printed out. You call this an expression because it evaluates something, or it expresses something, I guess I should say. Putting the +1 in there, now you would have 11. So you can intermix some degree of code in there. It does need to be an expression, something that returns something. You couldn't put another print inside of there, for example. There's a lot of ways to print in Python, and you'll see them all over the place if you look at examples. I tend to use this type in all of my courses and examples, but you can also do this, where it fills in a curly brace, and it does this, where you're just adding things together. Or you can use the % to replace a D or something like that. This gets into some important stuff. This is an if statement. This is how you make decisions. A is 5, so if A is greater than 5, then we're going to do this one. Otherwise, we're going to do this one. There's a lot going on here. You can see that I have indented. In a lot of programming languages, indents are white space. They don't matter for anything. In Python, they matter for everything. That is how you tell Python what goes with what. So this print, due to the way that it's indented, goes with this if statement. If I did another print, and I didn't indent it, then it wouldn't go with that if statement. It would print it right after it's done with it, but then this else would be dangling and not doing anything, and that would be an error. It's going to have to execute one or the other with a if-else. If you do want to compare that something is exactly equal to something else, you do this, double equal. Be careful with double equal and floating point numbers, because sometimes due to rounding, it may not be exactly equal to 5. It might be 5.00001. So often you just do a subtraction with an absolute value. So if you wanted to compare this, you do absolute value, a -5 less than 0.0, a bunch of them. That's one way to write a very small number, or you can use scientific notation, 1e negative, I don't know, 10. So that is another way that you can check to see with precision rather than requiring direct equality. Direct equality will sometimes get you into a lot of trouble. So if we run this, it's still saying that the variable is 5. I've just done a very precise comparison. Well, actually, the double equal would be the more precise. It would require exactly equal. But this would deal with some rounding errors that you can potentially get into numbers easy enough. This is how you loop over. This is like for 1 to 3, not including 3. So this is a loop. X is going to have all the values between 1 and 3 except for 3. And it's going to print at each one of these. So again, the indentation is telling it what goes with what. If this is the first time you've seen indentation in a programming language, this is your first reason to hate Python. It's mostly beat me into submission, and I like it well enough now. You can do lists and tuples. A list has square braces. A tuple has curly braces, tuple. I believe it's pronounced tuple. What is different is the list allows you to change it, whereas the set will not. If you tried to do this, you would get an error. So you can see the value has been changed. There's also a for each. These come in handy. When you get a list back of, I don't know, maybe you do a query and you pull all the people whose salary is greater than 100K, that might be in a list and you want to loop over it. So S is going to take on the value of every value in L, and it's going to loop through this indented section. So that's another way that you could print this out. Enumerate is pretty handy as well. I like this because if you're going to loop over all the things in L, it lets you do this I, comma L. So L is going to be the values 1 by 1 by 1, A changed, etc. But I is going to be the index. And the index starts at 0 in Python. This is a thing that manually adding items. Here I created an empty list and I'm just appending 1 by 1 by 1. So you can keep adding more and more and more. This is a list, so you can have more than one of the same value in there. In this case, we have 2 C's. You can access the individual values by doing print C1, so that's going to be the second one, so B. You can insert at specific locations. This is very handy. Here I have A, B, and C. I'm going to insert A0 at location 0, so it comes in front. I can remove values and I can remove indexes. That removes the 0th, the first one. This one removes the one that is equal to b. Sets do not allow you to duplicate values, and a set is denoted by curly braces. So here we create a new set. That's one way to create it. That would create an empty set. This creates a set that is initialized with A, B, and C, or you can convert a list into a set. All completely valid ways to do that. So here we create a set, we manually add A, B, C, and then we add C again, and you'll see that we do not have two C's. Also notice the order. The order changed. Very important thing. The order of a set is not guaranteed. You can also have dictionaries. These are sometimes called maps or hash tables. Here I've created a dictionary. It's name value pairs, kind of like a field and a value. The field is name, the value is Jeff. The field is address, the value is 123 main. And I can print that out. You can see I've printed out the dictionary. This is also very similar to JSON. Here I just print out the name, so it's Jeff. I also have a way to say if name is in D, then print name is defined. Because you want to be careful. If you just go to try to access something and it's not defined, you'll blow up on an error. A way around that is if you do d.get, so we're getting unknown key, but we're also saying, hey, default it to default. So if it's not found, it won't blow up. It's just simply going to give you default. You can access the individual keys and values in a dictionary. So here I have created this same one again, and I'm printing out the keys. The keys are name and address, because those are the two fields that we have. Then I can print out the values separately, Jeff and 123 main. So you can access those individually. This is a more complex hybrid use of lists and dictionaries together. This is very common. This is also very similar to JSON. Here I have customers, and this is like records in a database. Name, Jeff and Tracy Heaton, and then we have several pets. We have our two birds and our dog named Hickory. John Smith does not have as many pets. He has Rover, probably a dog. Jane Doe has no pets. So you don't even define it. You could potentially define it and do an empty list, but we decided not to do that. So we loop over all of the customers. We print out the customer name, and then we print out their pets. If they don't have pets, then we print no pets. So we're using that default. Otherwise, it would have blown up on Jane Doe because she doesn't have that value. Quick introduction to JSON. JSON looks very similar to this. JSON is JavaScript object notation. It is a way for JavaScript to store data in a textual form. Here we have first name, last name, age. So this is all very similar to what we were just seeing in Python. You have dictionary at the top, so that's name value pairs. And then you can also have a dictionary in a dictionary. So the address, we break it up into street address, city, state, postal, and so on. You can also have children, which is an empty list. So you can put lists in there. And the spouse, this person's single, so it is null, which is how you represent that in JavaScript notation. Now you can read this in Python just fine, but you need to change that to none. This is what it looks like if you expressed it in Python. You have to assign it to something. So this is JSON hard-coded. It's got all the names and values. And you'll notice spouse is none, which is how you represent a missing value in Python. Generally, it's better to read JSON from a file. Here, I'm just assigning it to a string, though, and then I am loading that string into objects, and now I can query it. You could also read this from a disk file. Now we're going to look at how to get CSV files loaded. CSV files look a lot like Excel. I have an example CSV file here. If I open this, it opens in Excel. This is Fisher's Iris dataset. Yeah, Office is always getting a new look. I just can't keep up. So we have here sepal with These are the lengths of iris flowers, and then that is the species of it. You can load that into Python just by running this code here. If you want to load the JSON in from a disk file, actually out on the internet here, I'm going to go ahead and run this, and now we have the JSON loaded. This file at this web location is basically just this stored off in a file. So you can access it from a file, you can access it from a network location. You can also read CSV files. CSV files look a lot like Microsoft Excel. Most CSVs, you can just double click them, Microsoft Excel loads them, and you have your data. So I'm going to go ahead and run this. This is reading a CSV file from across the internet that I have here on my data server. You can load it. This is a classic data set that contains information about cars that lets you do various predictions. I'm going to go ahead and display the first 5 cars. I do 0:5. And you can see we have the miles per gallon, the cylinders, displacement, horsepower, weight, acceleration, the year. Yeah, these are old cars. That's even before I was born. Origin and the name. So here we are going to query the data set. See, I'm going to look for the data frame because I loaded it here. It's in DF, the data frame, in pandas. And I am going to get every mile per gallon that is greater than 80. I'm going to get every mile per gallon that is greater than 18. And you can see there's quite a few of them. There's 398. Oh, wait, that's how big the whole data set is. But you can see I just got a list of trues and falses. The rows that have true should be included in the query. The ones that are false should not be included in the query. So you make use of this by passing it into the data frame, and now you get just the values, in this case, that were greater than 23. That lowers it considerably, just 201. It was the 70s. Cars were not efficient, but they looked cool. Now, if you want to query on 2 things, we want greater than or equal to 23, but less than or equal to 24, parentheses become very important. If you don't have these parentheses on here, it won't work. And you've got to do the single and. Run that, and you will see just the cars that have greater than or equal to 23 and less than or equal to 24 miles per gallon. You do all this nice work, you're going to want to transfer files. And there's several ways to go about doing this. We can map a Google Drive to CoLab, and then you can just copy files back and forth between CoLab and your Google Drive. I use that a lot. Or you can generate your data and upload and download. I do that a lot too. I probably do the CoLab to the drive more often, but we'll see both. So if you run this command, it is going to map your G drive to CoLab. And this is a one-time map. As soon as you close this and go away and come back, you're going to have to remap it. This takes a moment. I'll just let it run. All right. It's mounted at content drive. You're probably thinking, where's the C colon or something like that? No, this is Unix. There are no drive letters. Drive letters are a Microsoft thing. Is there any other operating system? So this is Unix. You can do exclamation point and then a Unix command. So I'm going to do ls content my drive. That's showing you the contents of my somewhat cluttered Google Drive. What you can now do is we can write and we can save a test CSV out there. And if we run this, now you have the CSV file written out there. Now, mine was already showing from my previous run, but it would have created it. It was not there. And then you can go into Google Drive and simply see it there. There you see it, and there's that test file. And if you open it, it actually opens it in Google Sheets. So there's the file. If you were to place a file there, you can simply read it like this. You can also directly upload and download. So if you know the URL of something that you want to get, you can just use the Unix command, bang, bang means exclamation point, wget, run it, and it will pull that file down. What is cool about this is you're running in Google CoLab, which is running at a high-speed data center. So you can download stuff very fast to Google CoLab. Now, it's being stored at this content location. So you can see it here, Auto MPG, the one that we just downloaded. The problem with this location is it's not permanent. As soon as you exit CoLab and come back, it's gone. So it's a scratch area. You're going to want to copy this to your Google Drive or just download it. So I'm going to generate another file, test.csv. If we list the content, we should see it, test.csv. That's my query of cars that were greater than 23 but less than 24. And now we can download it. Downloading, and see it's downloaded. It is now on my computer. I can click this and open it. And there are the cars that I queried. See, it's not the whole set, it's just the ones that had the miles per gallon that I wanted. You can also upload files. So I'm going to upload, I'm going to choose downloads, and I'm going to upload the Iris dataset. There you can see it's uploaded. And if we list content, you'll see Iris CSV. Okay, that's the introduction to Google Colab and Python. Hope you enjoy the course coming up, and I'll see you then. If you're interested in following with my ongoing course on deep learning, please subscribe to the YouTube channel and give this video a like if it was useful to you.